Okay, lesson 4-2. Lesson 4-2. So, pre-algebra. Simplifying algebraic expressions. So we have a lot of new vocab words, a lot of new vocab terms. We have, what, 7 of them total? So let's start with term. A term. Is there 6 of them?
The last word we didn't
Expression?
Expression is just for simplifying the expression.
Oh, gotcha. Okay, so a term. So when addition or subtraction signs separate an algebraic expression into parts, each part is called a term. So I'm gonna write a little, I'm gonna use their example. So they have 3x plus 7 plus x plus 2. So each of these different sections are separated by an addition sign, and it can be separated by a subtraction sign as well. So this right here, 3x would be called my first term, 7 would be my second term, x would be my third term, and 2 would be my fourth term. So those are my 4 different terms for this example. So our next vocab term is called a coefficient. So the numerical part of a term that contains a variable is called a coefficient. So for these guys, it is the number that is out in front. The number that's out front. So right here, the 3 in front of the x, that is my coefficient. And then for x, this would be the most challenging one that you're going to end up interpreting. So in front of x, there is a 1 because it's 1 times x. Whoops, I went black. 1 times x. So your coefficient for that one would be 1. 1 is your coefficient anytime you see x, and if there's a negative in front of it, it would be -1. So instead of this plus sign, if you saw a minus sign, that would mean it would be a -1. Does that probably help clear up some of the questions with the other ones? Yeah, okay. So that would be that. There would be no coefficient for 7 and 2 because they don't have a variable, which, oh, variable is not one of the terms. That's okay. Okay, so our next term is like terms. So that is when you are combining numbers that have the same value with it. So what does that mean? So 3x and x, they both have the same term behind them. So they both have an x. So I could take 3x plus x, and what would that be, Ellen? Yep, 4x. And then I would combine the other 2 like terms, which would be 7 and 2. And Madeline, what would 7 plus 2 be? Yep, plus 9. So my answer, when I simplify this down, would be 4x plus 9. So what happens if I have a negative here? What happens if I have a negative? So if I change the x, and I'll change that to a negative, because I already saw on your guys' homework that you have some negatives in there. That's where things get a little hairy. Okay, so when I'm going to identify my terms first. Oops. So first I have +3 as one of my terms, and -1 because of that negative sign. So when I combine those two, I'm going to have +3x minus 1, which would be what, Logan? So positive, when I combine +3x and -x. Yep, that would just be 2x. Yep, so when I would combine those terms, it would be 2x because it is a subtraction problem because there's a minus sign in front of that x. So when I do the other one, let's use blue, I have, keep forgetting to switch. So when I combine the -7 and the +2, Madeline, what's going to be my answer there? So -7 plus 2. +5, yep. So my simplified answer, just from changing up the signs, would be 2x plus 5, which is completely different from our other answers. So 2x plus 5. Okay, so when I was in pre-algebra, I actually used highlighters, just like I'm doing right now, and I would highlight when I had like a sign in front. That really helped me because I like color coding, and then it would also help me separate when there was a subtraction sign out front. So if that helps you, I would do something like what I did right here. That always helped me. If not, if you're having no issues with it, that's fine. You don't have to do it like that. And then our last term, well, not our last term, but our last one for right now is a constant. So an example of a constant would just be the +2 and the -7. Those are constants because they don't have the x. They don't have that coefficient with them. Okay. So I'm going to skip over example 1 because I pretty much did that when I rambled. Identify parts of an expression. I also did that one, but I want to do that example again because that one's a little bit tricky. All right, example 2. You guys okay with the door open, or is it a little distracting? A little distracting? Oasis, can you close the door? Thank you, bud. Okay, so identify parts of an expression. Okay, so I have 6x minus 2y plus x minus 5. So I have 4 different things going on right there. So how am I going to simplify this first and foremost? How would I simplify this? Just come up, put it by the jars. So I'm going to first identify these. So my like terms with the x, I have +6x, and then I have +x. So those are 2 of my like terms. Then the other things, they have different variables behind them. So my -2y, that's a different term. So I'm not able to combine that with the x's, and I'm not able to combine that with the -5. So the -5, that would be my constant. So that is a different term. So the only thing that I can do when I'm simplifying this is I can combine the +6x and +x, which would end up being oops. I'm going to have +7x, and then I just bring down my other 2 variables. So I have -2y minus 5, and that would be my simplified expression. That right there would be my simplified expression, would be 7x minus 2y minus 5. Okay, so that would be, I identified my variables in blue, green, and red. So those would be my different terms. So for my coefficients, I would have, in blue, I have 6. In green, I have -2. And then I would also have a +1 for the x. And then my only constant would be a -5. Yeah, Ellen?
So for 1 through 6,
yeah.
Do you want us to like simplify it, or do you just want to it doesn't say that we have to simplify.
No, you guys don't have to simplify. So yeah, you're just identifying the terms, coefficients, and constants. Okay, yeah, that's not terrible. So yeah, for that, you're just identifying. So saying what's the constant, what's the coefficient. So yeah, that's not bad. And then the like terms. So like for number 6 would be -4, -6. They are like terms because they have the same, wait, that's a P and a Q. That flipped in my head. So those are not like terms. But number 2, there is a lot of like terms. There's all those different x's. So 2x, 3x, and 4x, those are all like terms. Yeah. Yeah. Yep. And that P and Q, those are tiny. All right. Now we're getting into simplifying. Now we're going to get into simplifying. Okay. So example 3, we're going to simplify. We're going to do just letter A, since I've kind of combined all these examples into one example. We're getting into the fun part of algebra now. This part makes me excited. All right, so I'm going to try the hardest example, so letter C. I shouldn't say the hardest, the most challenging can be the most confusing. So I have 6y minus 3 times x minus 2y. So if you're trying to figure out where I'm at towards the bottom of page 179, example 3, part C. So we've already done an example like A and B earlier in this video. So part C, I have 6y minus 3 times x minus 2y. So what am I going to do first here? Madeline? Subtract 2y. So this is where we have PEMDAS. Here we go. So first we have parentheses. So I'm going to start with multiplying. This is positive 3y. So I'm going to highlight that because I want to remember that there's a negative in front of it. I have negative 3y. And then I'm going to multiply that by positive x. And then I'm going to multiply the negative 3 times negative 2y. So that's my first step. So I'm going to write this out below. So I have 6y, that stays the same. And then when I multiply negative 3 times x, Logan, what's that going to be? Negative 3 times positive x. Yep, negative 3x. Good, negative 3x. And then when I multiply negative 3 times negative 2y, Ellen, what am I going to get? It'll be positive because when I look at, yeah, because it's a negative 2 in front of that. Yeah, so it'll be negative 3 times negative 2, which would be positive 6, and then I add on the y. So I have positive 6y. Yeah, very important to watch those negative signs because they can, if you miss one, they can throw off your entire thing. So now, am I done from here? Madeline, am I done? Or am I, do I have another step? What's my last step?
Then we do the 6y.
So I don't have to do anything with that negative 3 because now is the point where I'm adding like terms. I'm adding like terms. So I'm going to identify my like terms. So in red, I have negative 6y, or positive 6y is right there. And then I have positive 6y right here. Sorry if that's hard to see. So I have 6y and positive 6y. I'm going to write over that in black. So I have, oh man, 6y and positive 6y here. So those are my only two like terms. The negative 3x, that's going to be just, I'm going to just bring that straight down. So I'm going to combine the 6y and the positive, both positive 6y. So I'm going to have 12y, and then I just have negative 3x, and I'm done. That would be my simplified version. So the ones where you're working with parentheses, those are going to be your most challenging ones because you just got to watch those negative signs and then combine it until you get to your very end right here. Okay. You guys okay with that so far?
Yeah.
Logan, you okay with it so far? Yeah, okay. So let's try the real world problem and then we'll be done. Example 4. Example 4. So write and simplify algebraic expressions. We're working with money. You have some money in a savings account. Your sister has $25 more than you have in her account. Wait, your sister has $25 more than you in her account. Okay. Write an expression in simplest form that represents the total amount of money in both accounts. Okay. So we don't know how much is in our account for some reason. But we do know that your sister has $25 more than you. So that's going to be positive because there's positive money because she has more than. If it was less than, it'd be minus 25. So since I don't know how much money I have, what would I do for that part? Yeah, I'd just do like an X, a Y, a Z, a P, an M. Since it would be money, I could do an M. That would also work, but I always like just using X's. That makes the most sense to me.
Why can't we just make math
So,
easy?
right? So I have X plus 25. That would be what I have right now. So that would be it written out right there. Write an expression in simplest form. Total amount of money. Oh, it wants the combined money. Oh, okay. So this is how much for just our sister. So sister has X plus 25. Sister has X plus 25. Now for how much we have in our account combined with our sister. So sister and me. I don't have a sister, but
No.
Nope.
You gotta know your brother.
Yep. So my sister and myself.
Who's your brother?
So how would I figure out how much that would be? Well, I have just X amount of money. And then my sister has X plus 25. So I'm going to put that in parentheses. So me, I have X amount of money. Sister, she has my amount of money, which would be X, plus another $25. So X times X plus 25. So if I were to simplify this, first I would have to take X times X. What's X times X going to be? William? No. Ellen? 2X. Yep. So when you have coefficients like this, if like just X and X, you are going to add them together. And then you have 2X times 25, which is going to be 25X. So 2X plus 25X. Okay. So that would be the combination of me and my sister. Evan? Yeah, make it quick because I'm about to do your guys' math. All right. That's all I have for you guys. So I'm going to move on. And if you have any other questions on your math, I will help you because I'm going to get through 6-5 math real quick here. 8-7 math, you guys doing okay so far? Yeah, Abby?